Hi everyone, I'm David Abood. I am a product marketing engineer here for the Altium 365 platform. So today we have the pleasure of talking with Mark Harris. He is a professional maker with over 15 years of diverse experience within the electronics industry, varying from aerospace and defense contracts to small product startups, hobbies, and everything in between. So before moving to Scotland, Mark was a principal engineer at one of the largest research organizations in Canada. Every day brought a different project or challenge involving electronics, mechanics, and software. Mark has published the most extensive open source database library of components for Altium Designer called the Celestial Altium Database Library. He has an affinity for open source hardware, software, and the innovative problem solving required for the day-to-day challenges such projects offer. Our focus for today is MCAD CoDesign and Enclosure design. So please add your questions to the Q&A panel. The chat panel should be reserved for supplemental information when your question is being answered. That way, everything's a little bit more organized and we can communicate a little bit clearer. So we're going to start off with a couple of polls. We just want to know a little bit more about everyone's background, what your role is, the mechanical tools, so that we can better create content moving forward. That's a little bit more engaging and, structured to your actual needs as opposed to what we think people need. Let's give that a little bit of time. And I'm gonna get some slides up here. Very simple slides. We're not doing anything too crazy right now. The idea is just to have an open discussion here. Of course, unfortunately, we can't have everyone talking with the way things are set up, but we got Mark here ready to go.
Yep.
Before we get started with the questions, a lot of people get confused on the differences between some stuff, so just a little bit of clarification. When we are talking about the software package, the actual part where we're designing the electrical stuff, we're talking about Altium Designer, which is the software that is on your computer. Whereas when we're talking about Altium 365, we're talking about the platform overall that is enabling connection to Altium Designer, to the mechanical tools that we're talking about. In the video, you use SOLIDWORKS, but you are able to use a variety of different tools that we can go into detail more later. All the tools that are supported are currently on the site, so you can take a look there. And then the last part we're talking about is the MCAD CoDesigner, which is the solution that is bringing you the ability to connect your design data with Altium Designer and all of the mechanical tools. So now that we got that going, we have some poll answers. I think we can dive into the questions. These questions have been pulled from your YouTube video, as well as a couple from a test AMA we did a couple years ago with you. I'm glad we're finally able to do this with you live. I think it's a lot more engaging and more useful than just the text base, So 3 topics that kind of split up. We have enclosure design, we have the CoDesigner and SolidWorks and MCAD tools, and then PCB Design Education. So we'll get started with the enclosure design. The first question is, what printer and filament did you use for this project?
I have a variety of PET filaments. So I primarily print in PET-G. I quite like how it works mechanically. It's nice and flexible, but still rigid enough, and very impact resistant, which is always really nice with enclosures, especially when you drop things and fumble a lot. So PET-G is a real winner there. And this is on a QWERTY iFast. Got a nice big build platform, but I'm also waiting for the Bamboo Lab X1 Carbon to come back in stock.
Ooh.
I'm really keen to get one of those. They are looking really fun. So definitely pros and cons between the two, but I think having two will be good. Historically, I've always been with the FlashForge Creator Pro. I've had that for, like 10 years.
Wow.
No, probably more like, no, it'd be 8 years now. But it started having a lot of extruder problems when I was trying to do this project. So I bought a new printer because it was going to be less hassle than rebuilding the whole thing from the ground up. It just needed a whole bunch of maintenance.
So, okay, the next one we have are, what are some of the challenges that came up during the 3D printing of the enclosure?
Well, getting used to a new 3D printer on a new project is always exciting. Getting, fine-tuning your profiles is always fun. So I do have several test prints, which we did. I actually ended up doing 3, but I was playing around with trying to get the plastic more transparent.
Yeah.
But the wall thickness is just too thick for that. It would have been really fun because this is a translucent PETG. So I was hoping to get the walls a little bit more transparent, but I think it came out pretty nicely in any case.
Looks beautiful, yeah.
Yeah, and I think it'll look really good when it's installed on what I'm planning to install it on. It'll be fun. But yeah, it's mostly just getting used to a new 3D printer. All the dual extrusion went really well, which is great because my FlashForge the nozzles were the same height, so I couldn't really do PETG because it's a higher temperature.
Yeah.
And PVA because the PVA would just burn onto the PETG nozzle, whereas the FlashForge bumps its nozzles up and down. So
that's really cool. Okay. Yeah. Yeah, I have my own 3D printer. I've been wondering about getting into I have a modular system, so looking at the dual extrusion as well. But that's cool that they have their own height. That
I was pretty
that would
skeptical
help a
about it
lot.
at first, but yeah, it
worked out.
It works out really well, and the dissolvable filament, fantastic.
So, do you know of a method that put the step model of the enclosure back into Altium Designer? So to have a 3D representation correct in a D for the electrical guy, but exclude the model from being pushed to SolidWorks.
Well, actually, you wouldn't export in a step model and put it back into Altium. In SolidWorks on the Altium CoDesigner panel, you can mark a part as the enclosure. So that will then get transferred back to Altium, and obviously it won't get re-exported back to SolidWorks. You don't need to worry about exporting step models. That's kind of the whole point of Altium 365 and MCAD CoDesigner is you don't need to be doing all that data translation, which is just absolute time saver.
Exactly. Like when we were able to add that for the enclosure, it was really exciting because you can move from either direction. If you start with an enclosure, you can come over and start making a board on the ECAD side, or if you already have the board, you can come over and start making an enclosure. So that bi-directional nature, and like you're saying, you don't have to make any, exporting is gone. All the communication is done through the Altium 365 platform, because that is where your design data is actually being hosted and stored. So that level of communication is very simplified, and you don't have to do all that back and forth.
Yeah, it really is a massive time saver. The next project I'm doing with MCAD CoDesigner is starting out with a basic PCB layout or basic PCB shape in SolidWorks.
Yeah. Oh,
then
nice.
Going back to Altium and building it out, but also having to then come back to the MCAD because it's got a bunch of connectors and such on the board, and having to create those openings in SolidWorks. So back and forth. If I was exporting parasolids or steps, man, that's a painful process going back and forth. So this is
yeah, like the other thing is the fact that it does incremental changes. So as you add more information to either side, only those changes are being communicated.
Which is a huge time
right?
saver as well, because
You know,
those step models get real big sometimes.
yeah, it's like you're done, right? And you just add a hole, you move something, and you have to redo the whole thing. No, like
Yeah.
that takes way too much time if you're
There's
just
another 1 gig
thing.
export.
Like, no, that no one wants to do that. You know,
No,
well,
really don't.
I mean, I don't know. Some people like watching paint dry, right? So, yeah, if that's what you like, that's fine. You know,
Yeah.
you can go ahead and do that. But
I like to be efficient. I like to get the project done in a reasonable amount of time and not
I
sit
think
there
most,
watching things spin.
yeah. So, how do you make the clear section on the buttons?
Well, this comes back to the dual extrusion thing. It's transparent PETG, and there's some good guides around on sharing platforms for 3D model files, and people like CNC Kitchen have some tutorials on 3D printed glass, which is basically just full extrusion, all in one direction, and just really maximize the extrusion width, keep the temperature down a little bit, and you get a really nice transparent finish. So yeah, that's what the center of the button is, and I think it came out pretty well. I'm really happy with it. Except actually these ones were done in PLA. I had some PLA to burn through.
Okay.
And yeah, the transparent section looks really crystalline and very cool compared, like PETG is a little bit more matte looking if you're looking through it. If that makes sense.
Yeah.
It's not as sparkly, and so yeah, I was really happy with that. As someone who rarely prints PLA, that worked really well.
How can I know the best clearances, what the best clearances are for my own enclosures?
Well, you got to grab your calipers
Good old
and figure
measuring.
out. Yeah, you've got to figure out what your 3D printer's tolerances are. The first prints I did on this 3D printer were just calibration cubes. So one of the reasons I bought it was a lot of reviews out there showing super high precision. I'm measuring it with a micrometer and getting within 5 or 10 microns of the desired size, which is just
that's nice.
Amazing. That's why I say in the video it's a piece of engineering genius, because I've never had that perfection in resolution. So yeah, you're gonna have to figure out how good your 3D printer is, or other manufacturing method using CNC machining, laser cutting, how good your manufacturing tolerances are. Probably want to double that, because you're going to have tolerances on the boards as well. I used 0.5 millimeter in this because I know I'm using through hole parts. They can wiggle in the holes on the board. I'm using the recommended hole pattern. So yes, you could shrink those down so there's absolutely no movement, but then you might end up with issues in production if you're mass producing something, and that it's just too hard for the assembler to get them in reliably or easily. So yeah, there's a lot of things which your tolerance stack needs to be considered. Look through the data sheets. Your manufacturer is going to have on every part a plus minus tolerance. You want to add up all those plus tolerances, add the plus tolerances of your manufacturing process, so you can really calculate out what the maximum error is going to be.
Yeah.
Because if you design everything phenomenal, you're going to end up with things getting stuck.
Yeah, I mean, I talked to a lot of people over the years about design rules, and it's like people think, oh, well, I defined the design rules. It's like, but physics are a thing, right? That's great. You also wanted the cheapest manufacturer.
Yeah.
So their
The
tolerances,
laws of physics are brutal. They really
know,
are.
and like I mentioned at the start, right? I just got a new AC system. They promised me a 9-inch duct. And then they're like, oh, there's only 5 inches of space. So I had to change my whole thing. Right? It's like it's just very small difference, right? You're trying to get that 9-inch duct, but gigantic trace through somewhere. Can it be done with the manufacturing process? You really have to talk to whoever's making the end product, right? Because you can know, again, you can make all those measurements, but if you don't have that precision, you need to
Absolutely.
adjust your design rules to be real. End of the day, so always make sure to talk to whoever's going to be making stuff at the end of the day, right?
Or you end up in the position where it is possible, but you've got to start shipping pallets of cash to the manufacturer rather than doing a bank transfer.
Okay, so where were we? Question 6. So in a previous video, you mentioned changing your design process, right? So someone asked, or your review process, is this the board you mentioned changed your design review process after production mistakes? Are you going to fix the design? If so, when will the project video for that be out?
I don't know when the video will be out, but yes, this is the project. So this is the control panel,
There we
which
go.
I used the LPC11U24 because it was in stock. I've used the series before, but it is a rather antique ARM now by modern standards. And being a first generation ARM Cortex, it does things a little differently because they were still developing the process, and the I2C, no, the SPI implementation was just the SPI slave implementation really is a bit weird. So really not easy to communicate with if you just use standard SPI from an yes, it is standard SPI, but you've got to toggle slave select for every single byte. So every
really?
byte you want to send, you have to toggle slave select.
That's efficient. Yeah, that's good.
So yeah, not great for running a display, even if it is just a character display. So yeah, I'm going to be switching that probably to an Infineon XMC 1400. I'm hoping to do that this month. So it probably means you'll see the video in about 3 months.
Yeah.
From the time of ordering boards to actually having a video out, it takes a bit of time.
That's another thing. Yeah.
Assuming I don't have any other issues. In which case you might see it in 6 months.
Yeah, there's like a couple videos in between of like, oh, well, this happened. So
Yeah.
okay. So let's switch up gears and now go more towards the mechanical co-designer and the different tools that are possible. So here you use SolidWorks. Of course, there is the ability to do the same thing with several other tools. So some of the questions will focus on that, but we can, Nikolai, I forgot to introduce Nikolai at the start of this. I'm so sorry, Nikolai. Nikolai is our PM for mechanical co-design, and so he is going to be answering some questions. I'm sure he's already been doing that in the Q&A section. Yep, he's busy going away. So some of your questions might be answered. We will go over them at the end as well. And he will join us to kind of give some more answers. But some of these questions that get asked, we'll kind of push it along to later. So does the MCAD CoDesigner only work with Altium 365, or can it work with regular Altium Designer? So I'll let you give your perspective as an outsider, and then maybe the more like official stance.
Well, yeah, I mean, I am definitely the outsider looking in on this. This is, but Altium 365 to me is just a part of Altium. It's like saying, how can I use this without using my file system? It's a great way of storing your projects, collaborating, version control. It's not, to me, a separate product. It's just part of your Altium subscription. So it's the storage for your MCAD CoDesigner. If you, the one thing I might say there is, if you've got a in-house Concord Pro server, which can do the same cloud functionality, because the question might be coming from someone who is in an ITAR environment or
Yeah.
an environment which is secured and cannot connect to the internet. And in that case, you would use a local Altium server to do the file translation and connect your MCAD to your ECAD. So it's absolutely possible to do it without Altium 365, but that's going to be more on a corporate level with a large company than a single like freelancer consultant sort of setup.
Yeah, so as you mentioned, so Altium 365 is a platform overall that is enabling these services, right? And so it is cloud hosted. As you mentioned, there are certain people that have government restrictions, ITAR, your security restrictions. There is something we're working on there to help out with that currently, but there has been in the past some on-premises solutions, like you said, Concord Pro and Nexus. So as we're moving forward, there's some restructuring there that we'll talk about in the coming months. But essentially, like you said, it is the part that is translating the design data through all of these tools. Your design is hosted on the workspace, which is your passing the information over from Altium Designer to the mechanical tools. So again, in this case, you use SolidWorks. You can use PTC Creo, for example. You can use Inventor and Fusion 360. So there are different
And
ways
Siemens
to
NX.
yes, that's new. That's a new one.
I'm excited to
So
try that one.
that's yeah, I haven't had the opportunity yet to try that. But you know, every time we've released to a new area, it's been a really nice, smooth process. Um, Especially when the architecture of the mechanical side is similar across the different platforms. It's really helpful. So yeah, like you were saying, it's all about how you want your design data stored. And the whole point of the 365 platform is to create a secure method to communicate between different disciplines. And I think every day we're growing. We have monthly releases, sometimes weekly of new things. So I recommend checking out the What's New webinars we have every month if you want to learn more about the platform itself and the capabilities.
Yeah, the monthly releases have been really stepping up. I've been super impressed trying out the new betas every month.
Yeah.
It used to be, hey, I'll update my Altium sort of once every 6 months or so, but now it's like, oh, what's happening in the next
Yeah,
beta?
the core ideology is to increase stability in a world where stability is important, right? We want to be there for people, and that's what we're doing. We're focusing on creating an environment where everyone can communicate effectively, securely, and be comfortable. So that's kind of what we're trying to do. And my team is focusing on getting people's story out there, like you, Mark, getting out there and actually talking to people about their experience and giving a platform to actually communicate that with everyone. So I'm thankful that you've joined us today, and you're able to follow up on your video that obviously very popular. A lot of people talk about it, and as you can see by all the questions, people have have follow-ups.
Yeah,
So the
Nikolai's definitely working his fingers off.
Nikolai's going. I'm glad I can just talk. I can rest my fingers until later. Thank you, Nikolai. So the next question was about, do you need any add-ins for SolidWorks? So we'll do the thing again, your viewpoint versus official viewpoint.
You go to the Altium page, go to resources support, downloads, just if you're downloading Altium.
Yeah.
It's got an installer. You run the installer for SolidWorks. Really couldn't be any easier. Go
Yeah, it's
into
like a
SolidWorks
2-minute.
and turn on the add-on. I tried it out for Inventor, and it was even easier in Inventor. You just install it. You don't have to go and enable it. SolidWorks
Yeah.
doesn't like enabling add-ons, even its own.
It really depends again on the tool and how they deal with add-ons. But basically, some people call them plugins, you know, whatever. Each tool is going to be different, but the installer takes like 30 seconds. It's
Yeah,
very
it's
low,
really
you know,
easy.
quick.
I was thinking it was going to be a huge hassle, but it
No,
wasn't.
no,
And
it's
then I
one of
logged
like the
in
easiest things.
SolidWorks, and
Yeah. And on the ECAD side, right, in AD, it's just part of the software.
yeah, there's nothing to
Right.
do at all.
So
Just save the
we
file.
wanted to make it really, really easy and simple. So I believe maybe in 21, it's just part of it. Like you just get ready to go. If you need to make any changes, right, it's an extension. I'm sure many of you are familiar with extensions inside Altium Designer. You can do your update if you need to, but okay, how do I enable the pull button in SolidWorks? After installing the add-in in the MCAD tool, I see a panel, but it wants me to sign in with my Altium account.
So
So,
sign in with your Altium account.
so
Select the project.
Yeah. Basically, as we were saying, the information is hosted on the 365 workspace. So if you're not signed in, how are you going to access?
And if you haven't activated your Altium 365 workspace yet, it's that process has gotten a lot better since the original Altium 365 betas.
Yeah, and you know, we have sample data in there so you can start playing around with. You know, I was working on that original data set 4 or 5 years ago when it was we made it for Concord originally. Actually, yeah. So basically, yeah, you have a bunch of sample projects. There's a multi-board design project in there. It's a little drone. So you can see different types of interconnectivity, different revisions of design data, all of that stuff, and components, right? How are components made? How are they defined? That's a huge aspect of all of this component management that kind of helps you get things along. Um, that's actually something maybe we could talk about later, the connection between the components defined on the electrical side versus the mechanical side. I don't know if anyone's interested in that. I'll pose the question here. You can add it back if you want to know more about how that works. If not, we have webinars. You know, you can look it up. So next question, how can I use other mechanical CAD software with these tools?
Download the
As we talked
installer,
about.
run it.
Yeah,
Easy.
it's all in the resources. Just install. 2 minutes maybe. That's including download, opening, getting coffee.
I was gonna say what's really fun is I had, when designing this enclosure, I had done it in SolidWorks. I was just running a SolidWorks trial, and I needed to make a small opening. So I'd forgotten to knock out a section, and my SolidWorks trial had expired by the time I got around to doing that. So I used the Inventor Altium 365 add-on to pull that and then edit it in Inventor. Which is great. So it's not just,
like just
if you've got teams with different software, it can kind of, you don't have any of the feature tree, but yeah, it's that was kind of fun.
Still better than the old cycle, right?
Yeah. Oh man, so much better.
Okay, so let's move on to our final, you know, predefined topic, which was I named it PCB Design Education. This is going to be more general. We have some questions from students, things like that, as well as some circuit design stuff. So the first one, what part of circuit design do you find is most overlooked in professional settings?
That's a tough one because
I know, right?
It depends on the professional setting. It depends on what the professional setting is building. So you might say, oh, simulation is most overlooked. But if you're building single board computers and dealing with DDR and high-speed buses, then simulation is sort of the core of the business. You're not going to, well, hopefully you're not going to order a board without running some simulation on the some EM sim.
Living life on the edge.
You don't just send it and hope for the best, because that stuff's really hard to test in the real world. You know, if you're testing DDR5, for example, and trying to see what's happening on every bit of the bus with test equipment, you know, that's probably 5 million in test equipment to be able to do that for every single channel. You know, you're looking at Keysight UXRs, a whole rack of them. Be lovely to have, but it's a lot cheaper to buy the simulation software. So in, I think, a lot of smaller businesses, there's not enough simulation done to do that, check that everything's going to work as you expect and try and catch those small bugs. I think that library management is always left behind in everything. So libraries are always a afterthought, or just a we'll just do something quick for now and fix it later, and of course later never comes. There's always something else to do. So yeah, it's going to really depend on the industry as to what it is. Yeah, absolutely.
So the follow-up kind of to that was, what circuit block do you find yourself reusing in several designs, and why do you like it?
I reuse microcontrollers where I can, but over the last couple of years, that's been a lot more difficult because supply chain has been incredibly painful. I'd say the same for voltage regulators. If I've built a nice switch mode power supply, I'm going to try and reuse that wherever I can. But supply chain has been incredibly difficult. So with microcontrollers, for example, I've been buying, if I think I'm going to use a microcontroller in a project, I've been buying 10 or 15 of them at the point where I start researching the microcontroller, because by the time I finish researching the microcontroller, it's probably gone out of stock.
Yeah. I mean, that's been a huge, I think everyone's been experiencing that. And
yeah, it's a challenge to reuse stuff at the moment, but generally it's going to be the simple bread and butter things: op amps, voltage regulators, microcontrollers, the stuff that's generic across designs.
Yeah. And that's something, you know, like as a sidestep on that's one of the main goals of the Altium 365 platform too, that like component obsolescence, supply chain issues, avoiding all that stuff. That's obviously a topic for a different webinar, which, you know, I know we have one planned up. So if you're interested in that,
Definitely one to look out
everyone,
for.
you know, you should check out. I believe John Watson is going to be talking about that. You know, it's a huge problem. It's getting a little bit better now, but with so many changes that have happened recently, it's still not, we're still not at 100%. And we'll see what happens moving forward. But I think planning for obsolescence, planning for shortages, is something that's really important. It kind of goes back to the last question, right? That's something that, because
Yes, absolutely.
we're thinking about now, right? We're
Yeah.
designing now. So like I want to get it done. I'm excited. That's why I became an engineer, right? To finish my product now. So it's hard to remember, like, am I gonna have to redo this in a couple years? Am I gonna have a V2? Right? How am I gonna make this system so if I have to change the IC, I'm not basically starting over.
Yeah, well, we've been using that a lot in Active Bomb with a client I've got, and every single part is basically, can we put 3 or 4 alternatives down, because
Yeah.
It's getting better. The supply chain is finally starting to catch up. You can buy STM32s now. It's amazing.
Wow.
I know,
Okay.
right?
That's good. That's really good.
They haven't existed for years. Well, I'm sure they have. It's just the big companies which want 100,000 of them have been getting priority over me, who wants 2 of them.
Yeah. Okay. Where do you think the greatest advancements still need to be made within the industry?
Well, if we're talking about electronics in general, I think that everything is advancing right now at such an amazing pace. We've
Yeah.
got in the power electronics, all the high voltage stuff, all the SiC FETs are coming out, and there's more and more of those basically every day, which is super exciting. In the lower power side of power electronics, you've got the GaNs, which are just pushing that efficiency and size down so much.
I just got some new chargers. They're
Yeah,
like powering my laptop, my phone, everything at once. I'm like,
yeah,
okay.
exactly. And you look at what SiC FETs have done for automotive. You're running inverters in a quarter of the size without needing cooling, which is incredible. Or they need a fraction of the cooling they used to. So yeah, that's super exciting. And the same thing in so many other aspects. Microcontrollers, there's a new microcontroller every day, and they just keep pushing the limits. And you look at what peripherals they've got in there. You can get microprocessors / microcontrollers sort of on the edge with 10 gigabit Ethernet.
Yeah.
And SATA and PCI Express in what's effectively an ARM Cortex. It's kind of mind-blowing compared to where we were 5 years ago. So I think everything is just going at such a crazy rate. It's not a matter of what's going to, it's what is.
Yeah.
And even manufacturing technology, you look at what the really budget guys are doing. They're doing stuff which 5 years ago was just unthinkable as far as size and spacing and tolerance. And the big companies, which were the original people pushing that, you look at what they're doing with HDI on the boards, and Harting with their 3D mid stuff, designing 3D circuit boards on plastic enclosures, which Altium supports now. That is so cool, and really, really big in the automotive sector.
Yeah, that's the molded interconnect devices.
Yeah, that's
some people aren't familiar. It's changing the game, right? You can, and that's something, like you said, is currently supported in Altium Designer. You can just create the 3D area, like route in 3D. It's just
wild.
it's
And
totally
stick
different.
components on the sides, and apparently it's
some of
really,
the like
really
concept stuff is really cool. And to be able to manufacture it too. Like going back to earlier questions,
at scale, not just in a lab.
Yeah, people can do that now, right? People manufacture these now. Like there are companies that are fully dedicated to this. So, okay, as a student who is now learning how to use Altium, what would be an interesting introductory PCB project to jump into?
This is something which comes up occasionally in my community and around the library, that is. And generally the advice is, as a student, that using David's video is just gone, that using something around audio is usually a really good option, because you don't need test equipment. You've got the test equipment built in, assuming you're not hard of hearing. It's something you can just, if you want to build an amplifier, you can hear if the circuit is terrible or not. You might not be able to refine that last 5-10%, might be at the edge of human hearing, but you'll at least get a really good idea of if you've done something terribly wrong.
Yeah.
Which is half the battle as a student. And you don't need expensive test equipment for it. You can use a couple of AA batteries and the output from your phone to create a audio amplifier for, say, a set of headphones or something. It's a area which I don't do anything with audio wise. I wish I had more experience in that, but I don't. And
project.
Yeah,
let's make some speakers, Mark.
I just bought
we'll
new
talk
speakers.
about this later. Yeah, me too. But you can make some. Yeah.
Yes, I could make some. I need to get a laser cutter again. I need to have room for a laser cutter. Yeah, the audio stuff's good. Voltage regulators, like switch mode voltage regulators, are not very glamorous, but man, they'll teach you a lot about layout and signal integrity and control loops. Even if you're not designing it, if you're just using an off-the-shelf controller, just understanding how that control loop works and how that drives the circuit and what the voltages and currents and frequencies moving across the board, and the stability of that loop based on the decisions you make in the board can be really important. It's definitely one aspect of circuit board design which a lot of people skip out on. So if you can have a really good voltage regulator, again, you don't need a huge amount of test equipment for that. Oscilloscope is really nice, but because of the frequencies involved, a $100 oscilloscope, a Rigol DS 1054Z is absolutely sufficient. Buy one used off eBay. They're fantastic.
You have like an article, right? Something like that. Like,
I have multiple articles on lab equipment, and because it comes up so often. What do I need? I have a nice equipment rack there, but which is getting some serious upgrades this year. But a lot of that stuff is fairly low end, other than the stuff at the top.
The stuff that can fall the most.
Don't say that.
Oh, sorry.
It's like $20,000 of stuff up there.
Last question from the predefined section. What do you think you value personally as while engineering, but seem to be missed by many engineers around you?
For me, it's always library management.
I mean, come on, right?
I kind of got a bit over the top on the library management side of things and built all my own tools for it. So I have a lot of really cool tools which I use myself for library management. A bunch of them are open source, but it's got to be library management and library management processes and building 3D models, like perfect 3D models for parts. So, the consistency of parts is a SOT 23 is the most arbitrarily implemented standard that exists. Like, it's plus or minus 2 to 3 millimeters in some case for different manufacturers. And when one manufacturer has acquired another manufacturer, like their package definition for SOT 23 is all over the place. Some are more like a SOT 223, some are more like a SC74.
All over the place.
Oh man. And then you get capacitors, and a 1206 cap could be 0.6 of a millimeter high, or it could be 3 millimeters high. So if you're designing an enclosure, this comes back to that tolerance question.
Yep.
If your models are not accurate and you haven't specified the exact part which is going on the board, which has the exact height, and you're trying to design an enclosure around a board which is 0.5 millimeter tolerance, but your 3D model isn't accurate for the model, like for the part you're putting on there, you can't fit an enclosure super tightly.
And that goes back to the standardization of the components and like the management of it, right? Because let's say you do put alternatives, but you don't have a standard of a height parameter across your capacitors. So great, they have the same capacitance, they have the same whatever, but like you
One's
said,
twice as high, and you substitute that in.
so it's about knowing what parameters are important for your process, for your designs. If you have very tight enclosure, you're gonna need to define things like that
And
across
also in the
components.
library as well, like
Yeah,
not just
yeah,
saying it's capacitor with
yeah,
0603
right,
as the
yeah,
footprint. It's got to be this exact Samsung capacitor is
yeah,
what is on the board, not it's
yeah.
just or then you end up in the case of, hey, we've got a 100 microfarad 50 volt 0201. Good luck when you go to order.
Yeah, good
Been there,
times.
done that. Not to that level,
Okay,
but similar.
so we have, we made it through the predefined questions. So let's go through the ones that haven't been answered real quick. We have a couple from Davey Baker. Hi, Davey. I haven't seen you in a while. I mean, I haven't done a webinar in a bit, so that's part of it. But nice to hear from you again. Um, so one thing we mentioned, the MIDs, molded interconnect devices, is generally how I refer to them. You are asking, how do we get that exported? Um, I am not completely familiar with the process right now. It's still something that's kind of being worked on, so I haven't gone too deep into it because things change, and I like to go into it when it's like, since I have to kind of know about everything, I try to dive deeper later on. So I can have Nikolai works with Jack. We should have Jack contact Davey to talk a little bit more about MID and what Davey's needs are there.
I would say
So
also talk to your manufacturer first. See what
again,
file format they want.
that's probably one of the
Share it
things
with them on
you value,
A365.
right? That's one of the
Yeah.
things you value that a lot of people miss again, right? Talking throughout the whole process to people. A lot of people are like, I'm designing, I'm done. It's like,
And like if Harting, who are doing a lot of the 3D mid, you're going to be able to chat with them. It's not like JLC PCB, where if you tried to share an Altium 365 project with them to ask their opinion, they're just going to be like, send us Gerber. It's it's a much more involved process, I think, which you're going to have more back and forth with the manufacturer. Get them involved early, figure out if what you want to do is possible, tell them what you want to have happen, and get them involved in the process early. Then you can share your files as you go, share your project as you go with them, and get some input from them. That DFM side of thing with any new technology, so critical.
Davey had a follow-up. Why isn't height auto-filled for a component? That's a really good idea.
From step file import,
that's something we'll talk about. I'll
I
talk
would
with
say also on that, a lot
yeah,
of people use very generic step models.
that is
And
true. They don't do yeah,
it may not be wise to pull the height from a step model, because if you're
because then they
using
attach a real world part to it.
if you're using a design rule check, it's going to look at that height property. If you don't, you can choose to do your design rules around the 3D bodies, which if you've got great 3D components, absolutely do. But there's also the option of just checking height based on the PCB height property. So if you've got a generic 0603 component model, which you've downloaded from somewhere, you're not experienced enough to create your own. Although Altium creates some beautiful models these days with the step generation. But if you're downloading something which Altium doesn't necessarily handle well, like a connector, for example, you've downloaded a 3D model, you may want to set that property manually based on the maximum material condition in the datasheet or 3D drawing of that part, so that
Definitely.
you can double check that 3D fit in Altium, because Altium's got multiple ways of 3D fit checking.
Yeah. And you can measure too, right? In that 3D space once you have it there. And one thing we were talking yesterday, you were saying you really like the collision detection. It's like the
Yeah, it's
pinpoints kind
easier in
of.
Altium than it is in other software because
Yeah,
everything turns bright green.
yeah. You're like, oh, it's
There's
right
something
there.
wrong with that.
That's not good. That's not good. Yeah. Okay. It would be great if you could talk about method to avoid MLCC cracking from the housing perspective.
I'm guessing if you're having that sort of issue, your housing has a different coefficient of thermal expansion than your
Yeah,
board. And it's
probably.
basically just stretching your board or compressing your board. In which case you probably want to look more at your mounting methods of the
Mm,
board in the enclosure. You might not want to go with a, really tightened down fastener to hold the board into the enclosure super rigidly. You might want
yeah.
more of a floating mount, some sort of rubber stopper like you see on the Noctua fans. You get a little rubber pull through, or the age-old standard plastic standoff with a little bump in it, so it just slots in and the board can shake around a little bit. Get a little bit of mechanical freedom in there so that you're not stretching the board. This also comes up with conformal coating. If you're doing conformal coat on boards, epoxy conformal coats are absolutely terrible for this. They're so hard and they have a slightly different coefficient of thermal expansion that your board gets hot and the epoxy just breaks components apart. So if you're having problems with thermal cycling or expansion, try and make it so your board's not so rigidly mounted.
Okay. Davey, you have a lot of questions. Maybe
Good to
maybe
see.
we
Good to see.
maybe we'll need to have a sidebar, but you might be able to answer this one. I don't see a complete way to do this right now, but Davey's looking for some G code out of Altium 365 for a 2D mill to cut the internal slots on prefabbed boards. Um, G code
Well,
generation is not right.
I would say, well, you get Yancey drill files. That's G code.
Oh, yeah, it is.
That being said, it's not necessary if you're wanting to mill in-house with a CNC router, some sort of even desktop CNC router, or a CNC milling machine, VMC, you're probably not going to want to run that code because it's going to make assumptions. Well, it doesn't have feeds and speeds. Basically, it's not a
Because it's just location.
yeah, it's just going to give you the toolpath to go back and forth. And if you were to run that on almost any machine, you're probably going to break your bit, or you're going to have a horrible surface finish. So I would
You
say,
use it for comparison.
yeah, fire up Fusion 360, install the MCAD CoDesigner plugin. Fusion 360's got amazing CAM capabilities. So that's computer-aided manufacturing. That's toolpath generation. Go in there, take your board. It's going to have all the origins and everything. You can fixture it in Fusion 360. You can set up your toolpaths with your tools, for your spindle, for your machine, and ramp down into the board and such, rather than just plunging full depth with a 0.5 millimeter wide bit and breaking it, because those are expensive. Just yeah, I think I would never run someone else's G code for that reason.
Yeah,
it's so machine specific, and Altium isn't a mechanical CAD package, so it doesn't do CAM. It'd be hilarious if it did, but completely pointless to 99% of users, or 99.999% of users.
Yeah, so they're talking about the 3D printed part, the MID stuff. So answer live.
You answered that one already. Yeah.
asking about movie creation for a blinking LED. I think we'll talk about that, Davey, ourselves. How do you allow third-party partners to download firmware for the PCB from Altium 365? So I mean, you could attach file types to project files. That that's kind of like a possibility. That's something that I think,
You could put a zip in your, like a zip
yeah,
file of the firmware in your project, and then that way the revision control would be kept
yeah,
if
and
you committed
you'd
that.
have the history of it. And when you do like project releases, you could put that in there. When you do a project release, there's a history view, so it has all the files, so you can reference that release and all of the outputs. So if you put like a zip file in there, you could do that. Um, that's
Apparently the browser
something,
doesn't show zips. You could use the new simulation tab. That will handle zip files and attach them to
that
the but I suspect
we'll
that
leave
tab
that.
is going to change in the future.
The idea of that tab is for a future of stuff like that, but obviously not right now. The idea is to be able to have more file types, but that also means you need to be able to read file types, right?
Yeah, people
So,
then start expecting diffs between your C files.
yeah, so we're working on things. So stay in touch on that. Um, you know, maybe you could help us test some stuff out.
Almost sounds like an idea to throw into the idea section of the forum.
Yeah, that's I always recommend going to the idea section and putting
If
stuff in
someone else
there.
hasn't already recommended it, then go ahead and
Yeah. I mean
add it yourself.
that's how decisions are made, right? Based on people trying to get that they talk about it and the community says it's important, so we work on it together. You only got history into an Excel. Um, there's an export project we're working on. I don't know what it exports to. I'm returning from paternal leave. I've been back like a week and a half, so there's a lot of new stuff.
Yeah, I mean, like I say, those monthly betas are going
I
gangbusters.
I've been catching up, and I'm like, oh, we did a lot of stuff. Okay, and we had our release in December. You know, the it's grown as much as my baby right now, my very tall baby. I,
Your baby is
guess
huge.
I should not be surprised that I have a tall baby, but I'm still, I mean, I'm still a little surprised.
Yes, your baby is the size of my 4-year-old.
They're about the same. Like, it's kind of crazy. We take him to a little gym thing, and he's like the size of the 18-month-olds, and he's 6 months. And I'm like, okay, but he can't walk or anything, right? He's 6 months, so he's just like a giant baby. Like,
Crawling tank.
he doesn't crawl yet. He just lies there. He's just a very strong baby that can't move yet. Luckily, since I have to chase him. Okay, so how do I let's go to the answered questions by Nikolai. At this point, we've done our time. But thank you for still being here. I guess I should do the last poll for people who want to kind of head out. It's just if you would like to recommend this webinar. I think we lost some people already. We got pretty deep into the questions.
Yeah. I was going to say the last question there is how to export a shopping cart with data sheets from my workspace into a zip file. Use ActiveBomb.
ActiveBomb. Yeah, that's it.
ActiveBomb is amazing.
Yeah,
Love that thing.
And there's the new procurement area inside the web view that's focusing on for people in procurement, right? So that they can get that live connection of the ActiveBomb document to the design. So as things change in the design, that kind of
is that available at all 365 levels?
Yes.
Or just
Yeah,
Pro?
it should. Oh, that's probably a pro. Like, that's like more supply chain.
Yeah, that's what I thought.
So yeah.
There's a couple of
Uh,
features which are Pro only.
how do I export metadata from my workspace parameters get notes? You can export to that. Now I'm reading Nikolai's answers. You mean to export MCAD or to something else? If MCAD, it's now not possible, but we are planning on implementing assigning the ECAD's project properties to the MCAD PCB assembly in CoDesigner.
That sounds cool.
It would be great if you could talk about cracking. If you have MCAD CoDesigner with SolidWorks error, unable to synchronize bodiless components, uh, which include multi-pads with the same size is not supported for now. How would you suggest I fix it? Simplest workaround is to move on the ECAD side. You just need to agree on the exact movement distance. So yeah, I guess if you're having synchronization errors, it's best to do that synchronization on the electrical side, and then agree and do that movement. XML to Excel. Mm, um, I want to see 3D objects in Inventor that's AD pasted in the PCB doc, pushed and pulled via CoDesigner. So free bodies or regular components is kind of the follow-up questions. So if free bodies, CoDesigner does not send them from ECAD to ECAD, assuming that they are part of mechanical enclosure, which already exist in the in MCAD. If components, it means that either Inventor can't read parasolids for some reason, or there's an issue interacting with the Autodesk Vault or other PDM. So support should be able to kind of help you out a little bit more. Best way to import Altium PCB data into SolidWorks. We currently use step files on the PCB with the components on. Step files are very large, and SolidWorks seems to really struggle, even if the step file is saved as a part rather than assembly. So yeah, I mean, we talked about that a good deal. Hopefully, Spencer got a little bit more information. I don't know if you want to give a quick rundown there. We have documentation that Nikolai linked out to kind of how to get this done a little bit better. But if there's anything you want to add, Mark.
I just say that, yeah, keep your step files in your library, obviously. And I found when I was bringing it in that it can take a while. SolidWorks is not the most snappy application. But once they're in, they don't need to be re-imported again and rebuilt again. So it's might be painful the first time. But if you're using MCAD CoDesigner, you only have to do it once. Whereas if you're exporting a step model of your board and sending it to SolidWorks every time, you've got to start that whole process again. So if you're dealing with a board which has got hundreds of components, MCAD CoDesigner is going to save you a ton of time, because that initial import is probably going to be a similar amount of time loading the step file versus doing it through MCAD CoDesigner. But from that point on, MCAD CoDesigner is going to save you a ton of time, because it's just going to update the changes. If a existing part has been moved on the board, it's not going to have to re-import the part. It's just going to shift where it is in the model, which is a real time saver when you're dealing with, I've got people in my library community who are complaining that their step files are 2 gigabytes for their project files. So you can imagine trying to import one of those into SolidWorks. SolidWorks is going to freak out. So having it all straight away translated to native files, yeah, it's going to take a while to import, because there's it's building every single 3D model you have on your board as a SolidWorks part with a full feature tree and stuff. So which is just incredibly amazing when you look at what's actually been implemented there. It's a real SolidWorks part, not just some import, and that takes a while for SolidWorks to run all the commands. But once it's in there, you know, it's if you want to move a part or add another 50 capacitors because you realize you know, power distribution network is not great, you can re-import that into SolidWorks really easily, which if you're working on a big project like that, which is integrated into something mechanical, you're going to be doing so many revisions back and forth as you try and get that board layout to the mechanical designers as soon as possible, as you're still working on the routing and still moving components. And the mechanical designers want to move the buttons because they don't like the ergonomics of it. And it's you end up with just folders full of hundreds of gigs of version 1, version 1.1, version 1.1 final going on. And it's like when you are then referring in an email to, you know, I need to move this button, it's like, well, which version are you looking at? And trying to follow that in the email chain, not much fun.
You know, the link to the latest design files, I think, is one of the
Oh,
most
absolutely. I
useful
mean,
things,
knowing that
right?
everyone's on the same page.
Right? Like you're all speaking, not only speaking the same language, but like you're in the same time zone. You're in the same time,
You're on the
like time
same
period, I
planet.
guess. Right? Like that's great. You're both speaking English, but one's 16th century, and
Or you've,
right.
like, the mechanical designers have got the last export,
Yeah.
but you've moved on and done a whole bunch of stuff since then, and what they're working on is out of date, but you haven't pushed it to them yet because saving the step file is such a hassle. So you only do it every Friday or something,
Yeah.
and they're after changes on a Wednesday or Thursday, and you haven't exported again. And suddenly you're trying to figure out, well, what component are they talking about? Because I've already moved that somewhere else for better signal integrity.
So we have a couple more questions. We've gone through our hour, but thank you if you know some people are still here. Um Dinesh says, I imported DXF file to Altium layout for PCB outline border and did all the layout. What happens if I need to change the board outline? How can I re-import the DXF file and move the layout? So Nikolai answered, if you are using the CoDesigner, you don't need to use the DXF anymore. You can just reshape the PCB in the mechanical side and sync changes with ECAD. The same is true if you want to do it on the ECAD side, you can.
Yeah, I think just go straight back into SolidWorks or
Yeah,
whatever software you're using.
yeah,
I'd also say if you are using DXF files to transfer board formats, that's the painful way to do it. If you're
yeah.
using CAD software, which doesn't support, doesn't have support for MCAD CoDesigner yet, use a step model for the board layout, because it's so easy to just, in Altium, say import board shape from 3D file and just click on the face. A lot easier than dealing with
It
DXF.
just does it, and
It's
you
so
can,
quick.
yeah, you can do depth and stuff too. Like there's
Yeah,
a lot of things. It's really nice.
but the easiest way is just MCAD CoDesigner, edit the board shape in, or the board part in
Yeah,
MCAD CoDesigner, and then save. And what do you know? It's
yeah,
done in the
yeah,
electronic side of things. It's the same thing as you said on the electronic side of things. Change your
yeah,
board shape, send it to
yeah.
the mechanical designers, and let it be their problem.
But my favorite thing is how we added the like I said, the depth, because it does the layers. So if you make it like you can change all of that, and it comes through. Is array embedded PCB support also something we will see? Altium 365 starts supporting multi-board projects. As for multi-board projects, they are currently in a closed beta mode, so they will be publicly available soon, sometime this year, hopefully. As for arrays, we assume you're talking about panelization.
I
Just
would
trying
think
to,
so.
you know, that's generally what people mean. Um, and Nikolai said UPD, if it still matters. Panels in Altium 365 are also in closed beta. And I think that's because I'm going through and these questions have already been answered.
There's one I'd like to answer is
Yeah.
Michael's asking, saying most of our boards are rectangular and situated in big rectangular boxes with lots of room. Is there
Okay.
much value in linking Altium and SolidWorks in this situation? And I'd say if your board has butts up against the enclosure for any openings whatsoever,
Yeah.
yes. If
Yeah.
it is just a industrial cabinet where
Yeah.
the board is just floating in there and everything is just harnesses off to panel mount stuff, I don't think that your MCAD people are really going to care unless you're adding a lot of mounting features on your board, which have to line up with the enclosure itself. And it's not it's not just a standard injection molded part or sheet metal part, which you buy off the shelf, which if your team is designing those mounting points, I'd say there's probably some value there, because then you can at least double check that everything is in sync on the board so that your mounting holes are correct. And if the mechanical designers decide to change things on you, as they are very painfully do, and then you don't find until you've gone to fabrication and you've got 500 boards which don't mount on the control panel.
Good times.
Then yeah, there'd definitely be some, if your board interacts with the enclosure in any way other than just floating inside, if it's a custom enclosure, absolutely. If it's a standardized enclosure but you've got openings which are cut out for your board, it's going to make their life a lot easier if they can just do sketch geometry around your parts. It's going to really save a lot of time. But I say, if it is just a board floating inside a enclosure, it's not a huge amount of benefit, perhaps.
Yeah, and like Nikolai,
But there's nothing stopping you.
Yeah, Nikolai had a couple things. The speed of the exchange, since it's incremental, right? Anytime things change, it's just the differences. If you do any simulations, you can build out the 3D copper geometry in the mechanical side to do simulations. If you have mechanical constraints, as you mentioned, Mark, you need, alignment. That's no brainer. Like, it's going to help you with alignment. The fact that you can change the enclosure, you can change the board outline, you can change any of that on either side.
The other
Huge
thing I'd
help.
say also is, if you're doing mechanical simulation, if you're doing FEA for or flow sim, so if you're wanting to simulate thermals in SolidWorks, if you're wanting to simulate the airflow through an enclosure, then you want the actual board geometry up
in
to
there,
date.
the whole thing,
and up to date regularly, without having to do that huge email chain of which version are you dealing with.
and that's kind of last thing on it was the representation of the copper, the solder mask, and the silk screen. That can help you in a lot of situations. So those are the questions. That was it. I think that was really in depth. It was a lot of fun. Hopefully we can do some more stuff like this in the future. We will need to be my goal is to kind of create a supercut of the questions we get here and the questions we get later at the US one at 11. We will be sending out that supercut recording essentially, and I think we can add some follow-up links based on the questions. Like, for example, a link to your article on testing equipment, right?
Yeah,
It seems like a lot of people are interested in, like,
stuff you want for your lab. It covers all sorts of things,
right? Because there's two sides of people here. There's the professional and there's the hobbyist, and there's the professional hobbyist. Right? It's like, sometimes you're a professional, but you want to do stuff at home. And
I also try and make it so my articles are applicable to both sides. So, talking about test equipment on a bench, it's going to have basics like, having flush trim cutters, but it's also got some things like a Volterra V1, which you're probably not going to have as a hobbyist, but as a professional, it might be a really valuable tool for you. It's That article's got a lot of stuff in there, which might just give you some ideas of how you can be a little more efficient, or things which just make life easier.
Okay, thank you, Mark. I will see you in a couple of hours.
Yeah, I'll see you too.
Get some rest. I'm gonna get
Let's
some
do
more
this
coffee,
again.
and I'll see you soon. Thank you, Nikolai. Bye, everyone.